I've also changed it so that way it's at 720p instead of like something else. I just need to view the watch page on YouTube, and that's it. Let me just make sure that it's working fine. So part 2 is going to be basically part 1, in which I'm going to go back to the basics, because a lot of the content that I've been learning, it's not freaking the birds are making a lot of noise. So yeah, I'm going back to the basics here. So I'm gonna go from page number 31. I'm going to skip chapter 1 because majority of the time I haven't really had to deal with chapter 1. My professor requires a lot of different type of things. Like I already have my first project, but I don't know how to actually start it up. So I've been contemplating on rereading this entire thing because I don't actually remember majority of the content that I learned the last time I did this. So we'll start from the beginning here, in which it goes through IOStream, because this line starts with blah blah blah. Yeah. So we already know how to use cout, okay? So basically it's something like this, cout. Let's also use the namespace database. Alright, so we already know how to use cout, and as I said in the last stream, cout is left out, so then it'll be like this, and then we'll say, oh, the program works, and then we would end it with the semicolon. Okay, so now we test the program out to see if it works. It's gonna go super fast, so yeah, just give it a second here. It's gonna show a black screen and it's gonna go away. There we go. That's it. So that's done. You know how to use cout properly. What we do need to figure out is the more complex commands. We know that we always need int main before we begin coding a program, because if you want to find out where the program actually starts, start at int main. I should actually somehow check the comment section as well, but I don't know how to do that. So I'm just gonna keep on streaming it. It should show it here, but it's not showing anything, so I don't really know. Anyways, I'm gonna move on here. So let's see. So this is called a string. This thing is a string command, at least that's what I think it is called. I don't actually know, but I'll figure it out. An important concept in 2.3 is, although the output is broken up in two programming statements, this program will still display the... Alright, I should actually... I didn't say what I was doing. So this is C++ programming. It's a class that I'm taking. It's an introduction to C++, or I guess it's an introduction to computer science. Not many people use C++ anymore, but the class that I'm taking requires me to learn C++ programming, which is the reason why I am doing it. But my professor is not very good, and that's the reason why I am learning the programming language on my own without any help, because the professor doesn't really help. So so with that said, the next thing that we need to worry about is actually this one, in which you do cout, right? And let's say that I do something like, oh yes, the program works fine. Okay, so since we did that, right, I should probably add period there. Okay, so when we print this out, what's going to happen is it's going to write it in just one line. I don't actually remember how to pause the program, but maybe it is like this. Give me one moment. Is this how you do it? I don't actually remember, but maybe this is how you do it. There we go. See that? So with the system pause command, I'm able to show you how this works. So due to this, as you could see, it's all cluttered. It's like, oh, the program works. Yes, there is no like spaces, etc., etc. Oh, well, I spelled that wrong, but there are no like spaces and stuff like that. It just says the program is fine, and then it goes press any. I press this space, goes back. So how we can fix that is by using the end line command, which is one of the ways to actually do it. There are multiple ways, and I'll show you that as we go on. So basically, we're going to add more cout commands, and what we're going to do is we're going to add the end line command right over here. What's up with this? I don't know. Oh, why did it do this? Okay, end line. Okay, so now since I have end line command there, wait, wrong. Oh, that's why. There we go. I should fix it. Okay, so now it should look a lot better than it did before. As you can see, oh, the program works. Yes, the program works fine. And then it says press any key to continue. You could actually change this message to whatever you pretty much want. And we'll get into it, but not right now. Speaking of which, I should probably include conio.h. All right, so let me fix. Program works fine. All right, so that's that. Next up is to learn other ways to actually do the line stuff properly. Okay. The other ways that the book shows you is instead of putting end line command there, we can just do this. We can do forward and do forward n. Instead of keeping the end line command, and that way it'll make it so that it still does the same function, but it does it a bit differently. Well, it doesn't do it differently. It pretty much does the same thing, but as you can see here, this is not in a separate line, so I guess for this I would still need to add end line command, so that way the last line splits up here, so it looks neat. See that? These two look the same, but this one was messed up. That's the reason why I put the end line command there. But with the other way, you don't really need to do that. But we'll go through it. So far so good. I understand everything. So we're gonna move on here. All right. You could also do stuff like this as well. Like, let me see if I can show you. Like, for example, if you wanted, you could put a /a there, and what that's gonna do. Wait, sorry. Is that wrong? Oh, okay. It is wrong. Just give me one sec. You're right. I guess I can't use this with end line, but be able to do it. Okay. So what this is gonna do is it's actually gonna make a beeping noise. See that? So there are multiple types of commands here. There's a new line or horizontal tab, blah 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 blah. So So we're gonna move on, and we are gonna go into the next step. Yeah. Okay, it goes into more examples of using cout, but we already know how to use cout, so we're not gonna continuously go through the same thing over and over and over again. Okay, so just for a refresher, this is a comment. These are the libraries. This is where code this is where everything works. So int main is where you always start your program. The int stands for integer, and the main stands for main. Cout, as we've already discussed, means that you are sending out output to the person. Like for example, if I put C in there, actually, I'll just show it in the next example, but all you need to know is that cout, that you are outputting the information to the user or to whomever is watching the computer screen. Okay, and system pause is just there to pause the screen so you could see what I'm doing. And return 0, it says basically to return the integer back to 0, and that's how the program functions. I'm not exactly sure about the details of this, but as I go further, I'm sure I'll figure it out. So with that said, this is going to be a pretty long stream, I think. Yeah, it's going to be pretty long, so hold on tight. If you have coffee, probably drink some. Okay, let's see here. Variables and literals. Variables represent storage locations in the computer's memory. Literals are constant values that are assigned to variables. Int number. Okay, so here's something new. Integer number, this is called a variable definition. It tells the compiler. Let me actually just write it down here. So instead of this, let me add it here. Okay, so int number is what it's talking about now. Okay, so it says that this is a variable definition. It tells the compiler the variable's name and the type of data it will hold. The line indicates the variable's name is number. The word int stands for integer, so number will only be used to hold integer numbers. Later in this chapter, you will learn all the types of data that C++ allows. Okay, so basically what this means is that the integer will only hold a number. Okay, it's going to only hold integer numbers. Okay. So an example of that would be right over here. Give me a moment. So the example that they're giving me is number equals 5. Then it says cout, left out. The value in number is, then you do one more, and then you do number, then you end it. But instead of me ending it, I'm going to have to use end line because that way it splits up. So now what this is going to do is I've defined that the number is 5. So what it's going to do is it's going to take the number and it's going to output the values. So now the word number is basically 5. Okay, so watch. See, the value in number is 5. the value in number is, and the number, and then 5. So this basically means that I am outputting another command here. Well, I'm not actually sure what exactly this means, but what I do know is that in order for me to output a variable like this, I need to use the left out symbols. So with that said, the program is complete. Move on. Now, if you put quotes on this number, that's the next example that they're showing me. What it's gonna do is it's going to basically say the value in number is number. So you don't want to do that. You want to make sure to not mess this up, which is quote stuff. So always make sure. Now, if I change number to, let's say, number, it won't let me do it. So I thought that it might let me do it, so I could show a better example. But let's say that I changed number to number 1, and then I changed number to number 1. What it's gonna do is it's gonna give me an error because number 1 is undefined. Okay, never mind. Don't listen to me. I don't know what am I doing. All right, let's just keep on following the book here. Of course, we start experimenting. But anyways, basically you just need to remember to not put quotes on everything, because once you put quotes, it's going to read it as the common thing. Yes, I don't know. Anyways, moving on. Sometimes a number isn't a number. As shown in program 2-6, just placing quote marks around a variable name changes the program's result. In fact, placing double quotation marks around anything that is not intended to be a string literal will create an error of some type. For example, in program 2-8, the number 5 was assigned to the variable number. It would have been incorrect to perform the assignment this way. This line 5 is no longer an integer but a string. Okay, so once I do this, things inside the quotes become a thing called string literal, which means that it is no longer a number. It basically says here, the fact that numbers can be represented as strings frequently confuses students who are new to programming. Just remember that strings are intended for humans to read. They are to be printed on computer screen or paper. So like I said, the strings are there so that way you can output the information to the person, as in like asking the person what's the time of date or how much do they get paid or something like that. Okay, so moving on. I'm just gonna turn off the AC that's running in the background because I feel that it's creating a lot of unnecessary noise, so give me a moment. Alright. Alright, I think things should be a lot more smoother. Okay, I think they're teaching me something new here. Just a second. A literal is a piece of data that is written directly into a program's code. One of the most common uses of literal is to assign a value to a variable. For example, in the following statement, assume that the number is an int variable. The statement assigns the literal value 100 to a variable number. Another common use of literals is to display something on the screen. For example, the following statement displays the string literal. Welcome to my program. Yep. Okay, so let me just read this real quick. One of the most common uses of literals is to assign a value to a variable. I see. Okay. So majority of the time when you use this int, it is generally used to assign a variable. Like what I mean by a variable is like some type of word to a number. So in this case, we've assigned this. We have assigned number to number 5. We could actually change this and let's say apples, right? Oh, and we can so since the integer is apples, we can actually change numbers or number to apples. Now apples will always equal to 5, which means that the fruit of the day is, then we could change this to apples, and what it will do is it will display apples 5. So it is 5. But that's not what we want. So if you didn't want this, what we could do is we could if you didn't want this, what we could do is instead of doing apples, we don't output anything, and we just keep this like the way it is, and we just do is apples. And what'll end up happening is that it'll just say the fruit of the day is apples. But we're not going to do that here. We're trying to output more commands. Anyways, we're moving on. So the example that they've written here is this. So just give me one moment as to write it down, and then I'll explain it a bit more. So what it says here is today sold. We have a space and then apples, and then says output another, and then it's using the slash. So instead of using end line here, it's actually using the slash and at the end of it. So then it's bushels of apple. Oh, sorry. So like I said, the forward end stuff can be to, all right, can be used to. Oh, okay. So whenever you use the slash n command or forward slash n command, you also need to include it inside the string literal. Okay. If you don't include it, then the program or then the program will not know what to do with this. Okay. So now let's test this out. Today we sold 20 bushels of apples. So as you could see here, you could split these words up too if you really wanted to display the message. You could have also done it this way as well. Oh, I might be making this a bit too confusing. Hope that is not. So we could have also done it like this. Sold. Oh. Well, we would have to change the, I guess, the sentence structure if we wanted to do it differently. So then it would say, today we sold apples, and then we could also do, we sold to apples. So I actually messed this up, so I need to quote there. Now, since we didn't add the end line command, you'll see what happens. See? All like funky, and the reason why it's messed up is because I didn't put a quote, I didn't put a space there, and I didn't put a space there. Now, if I put two spaces at the end of them, what happened is that the apple is, but this is still there. So the way we can get rid of it is we could either do /n. So the reason why I'm putting so much emphasis into this is because you'll be using these commands very, very frequently. So, and we could also do it like this. Give the same result, but you just have to write additional. Okay, so with that said, let's move on here. Okay, I think a zero, this returns zero. The zero is actually called integer literal. This we are moving on to constants now, which is a bit different than the regular stuff. Okay, so they have an example program here which says this program uses variables and literals. Okay. Oh, right. Now it goes further into this. So you could have multiple integers. Like for example, we have apples right now, but we could also have stuff like bananas. Bananas. Okay. So now we have another integer now, which is bananas. Now, since we have another integer, what we're going to do is we're going to define this integer, which is so bananas equals to 10. Okay. All right. So since bananas equals to 10, we're currently only using apples. So what we want to do is today we sold apples. Wait a minute. Oh, we sold. And bananas today. Okay, so now we're going to output this and we're going to output bananas. I'm not sure if this is gonna work. Try it out though. Okay, things look good. Let's see if it shows it. See how it shows it. 2000, 2010 apples and bananas. Okay, so we need to separate them. Let's see if it actually shows it how. Okay. I wonder if there is a way to output both of them but not have them, like if there is a way to separate these. I'm sure there is, but I don't know it yet. So instead of doing it like this, we would have to do it something like instead of doing it like this, we'll keep the original line and remove the bananas. So we have apples today, and then we have out bananas were not very popular. Sold only have a space there, and then you would bananas. Sorry. Okay, we got it. So now it's going to show it properly instead. Sorry. Oh, okay. I wonder if it's possible to actually do it got it. See that? That is good. Now it is today we sold 20 apples. The bananas were not very popular, and so only 10. And it has the period at the end there too. Kind of silly, but all right. So with that said, we are moving on. We know how to use integers command now, because your command, like I said before, always means that we are assigning like a string literal to a number. I think I have my definitions mixed up, but that should be fine. Okay, so moving on. Next up is it's still continuously giving me more examples about this, but I'm not going to doing this. Okay, so basically this is called an integer literal. This is called a string literal. This is called an integer literal. Okay, so numbers are called integer literal. Integer literal. Blah, 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 blah. And words are called string literals. They're string literals. And this is integer literal. There you go. All right. Moving on. Moving on. Use variable names that indicate what variables are used for. An identifier is a programmer-defined name that represents some element of a program. Variable variable names are examples of identifiers. You may choose your own variable names in C++ as long as you do not use any of the C++ keywords. The keywords make up the core of the language and have specific purposes. Table 2-4 shows a complete list of C++ keywords. Note that they are all lowercase. The majority of the commands that you can use in are all lowercase. None of them is uppercase or anything like that. All right, so moving on. Int x, int items ordered. Okay. Just go through this here. So each time you are inputting a command that is colored in either blue or whatever theme you are using, these words always have to be lowercase. They cannot be uppercase and lowercase or anything like that. Okay? So with that, moving on, we can actually change this stuff to whatever we pretty much want. So let's say we wanted to do app. We also need to change your value as well. So instead of it being like this, it'll be like something. Now they're both compatible. So let's say that we wanted to do bananas as well. We would do BA. We would capitalize that. BA. But since we are making changes here, we also need to make changes here so that way the system understands it. Okay, it's capital B and capital A. Okay, so now since everything is pretty much the same, the program is going to work just like it did before. It's going to say apples and bananas and etc. But it's not gonna matter. But the only thing you cannot change is this stuff. So now since I've done capitalize, try to run the program, I'm going to get build errors. So can't do that. Don't do that. No matter how much you want to do it. that's what it's basically teaching us here. So we're gonna move on. Now, another example that is showing us is like stuff like, let's say that you are putting the word items ordered. Okay, now this will work fine, but to the person that is reading your code will not be able to understand it. So which one would be easier for you? Sorry. Um, okay, so which one would be easier for you to read? Would it be the top one or the bottom one? It is the top one. Why? Because it has the capitals there, which is item, items, ordered. So that way it is easier for you to see it. You could also add this as well to make it easier for the person that is reading your code to understand. So this would make it easier for them to know what this variable actually means. Okay, so we're gonna move on here, and we're actually gonna actually a lot of things. I'm gonna change it so that with bananas and apples is was before. Okay, there we go. Oh. All right, that should do it. So we're back to the original code. I gave you that. Okay, so there are a couple of rules when it comes to variables as well. Like for example, if I did but wait, yeah. So for example, if I did it with three, the variables cannot begin with an integer. So you cannot make a variable that has a letter in front of it. It is not gonna work. So don't do it. Okay. With that said, okay, so the rules that you need to remember is that the variables can only use letters, digits, and underscores, which is a reason why the underscore worked fine. So in this case, the underscore in front of apple and bananas and stuff like that will actually work fine because underscores are acceptable by the C++ programming language. Okay? So you can't use stuff like this. Like you can't use you can't use the pound sign. It's not gonna read it. So things to remember. So now, since you cannot begin with integers, but you can end with integers if you really wanted to. So for example, we do 9. Everything is cool. Everything is cool. This is not cool because it doesn't know what apples is, because now apples is apples 9. So if I remove that from the entire equation here, they'll read it fine, and then it'll say, oh, everything is cool. See, int apples, which is right over here. So, okay, rules to remember. Write it down as a comment. I'll write more comments up top here. So rules to remember is to not use with not start do not start variables with number. Don't use only use letters. digits and underscores. There you go. Do not start variables with a number and only use letters, digits, and so there you go. So that's one rule that you must remember. The other stuff that we learned was that the int actually means integer. Okay, so since int actually means integer, generally when you use integer, it is when you are assigning a variable to a number. So int assigning a variable number. Okay, so that's the next one. Other than that, we haven't really discussed more. All right, so another thing to remember is that and end the lines by using /n or /n, sorry, and line. Okay, so these are the, I guess, the most important things. All right, so another thing, sorry, cout display information. So you also need to remember that when I'm doing these slashes, it basically means that this is a comment. Whenever you begin coding a program, you always want to do something like this, so that way the person that is watching your source code knows what the program actually is doing or wants to do. Majority of the programmers that you will see, if you see the source code, what you will see is a comment at the top, and majority of the time when they're coding in C, well, actually almost all the time when you see people coding in C++, their program will begin with this dear main, and then they'll start coding, and you'll see the libraries used, and so anyways, moving on. I think this is the most important information that I've discussed so far throughout this entire tutorial. Tutorial? No, it's basically a learning thing in which, like, I'm learning this, and maybe somebody in the future may watch this or is watching this that might be interested in learning this as well, which is the reason why I am doing it. So moving on. It has integer data types. Data type sizes and ranges shown in table 2-6, which you cannot see, are typical on many systems. Depending on your operating system, the sizes and ranges may be different. So if a person is using something like Windows XP and you are using Windows 7, the The data type sizes and ranges will be different depending on which operating system you are using. They're even different when you're using, let's say, Windows 7 64-bit and Windows 7 32-bit. Now, I don't know exactly what do they mean by data type sizes, but we'll find out as we go further. So we're going to move on, and I'm gonna have to remember these data types from the looks of it, because a couple of them are 2 bytes, 4 bytes, 8 bytes, and the bytes go crazy when they're 8 bytes. It's like 18 bazillion. Crazy. Of the data types in table 2-6, except int, abbreviated as follows. Just gonna skim through this. Just give me. Coffee's getting cold. I'm gonna. Look, I'm trying to look for an example. Okay, all right. So there's an example here. Note says the long integer and the unsigned long integer data types were introduced in C++11. So the 11th revision of the C++ language. All right, so we're going to move on. As mentioned before, variables are defined by stating the data type keyword followed by the name of the variable. In program 2-10, an integer, an unsigned integer, and a long integer have been defined. Curious about something, so give me a second as I test this out. So now I have the variable apples defined as an integer, and the apples is 20. So what if I change the apple to, let's say, 2 whatever? Say we change this to a long number as well. Will the program still function? Is the answer is not correct. Interesting. So depending on how big the number is, it actually can go only so far. Today we sold. Okay, so that's why we have the different data types, is because you can't just use int or integer for any sort of number, because if the number goes very high, it's just going to give you the maximum value of the integer, which means that we need to actually, let's go back for a second here so I can actually show you stored int. Okay, so the largest number it can go into is, let me write this down here just to verify that I'm correct. Okay, so since we put apples for, I don't know the number, what we're gonna do is we're gonna put the integer 2147 483 648 648. Okay, so now this should display the same number. Okay, so it did negative before. Why did it do negative? Oh, okay. Okay, so you add 1 into this number, it's going to go straight into negative. Now, if I wanted to, I could make this a positive number by changing the 8 to a 7, and it's not going to be negative, it's going to be positive now. So there's a limit to integers. Okay, since there's the limit to integers, there's different types of data types in C++ programming. Depending on the length of the number that you're trying to find, you will need to use a different, what was this called? Integer literal, to define it. Like, so now since apples is just an int, we change the int of the apple to, let's say, long int. Okay, long. Now what that's gonna do is that, now so the last time when I had this to 8, it changed to a negative, right? Now if I change it to 8, it's going to be a positive. So depending on the amount of numbers that you're using, you will need to use a different integer literal. That if bananas, now see how bananas is an int. So if I use the same thing here, right, for bananas, what's going to happen is that the bananas is going to show up as a negative number. Now, if I change, let's say the integer literal to long integer, what's going to happen is that it's essentially not going to show a negative number anymore. So depending on the number that you're using, you're going to have to modify the integer literal. So I know this is a lot of information, but because I'm in the same boat right now. Which means that remembering the integer data types is actually really important when you are coding the programs, because you don't get this. All right, this is part of the reason why when you are playing video games, what ends up happening is that, let's say that you let's say that you are cheating in a single player game, and let's say that you are modifying the money of the game. Now, if the coder did not use like a long integer or anything like that, there's going to be a limit to how many items you can actually hold. Now, there are times when you go above that value. Generally, that value is capped at the maximum integer value. But when it's not capped, it can go into a negative number, which means that you have a negative value of a specific item. So if the programmer used the long integer, then that would mean that you could go way beyond whatever is possible. Yeah. So what I'm trying to say is that it depends on what type of integer value you are using. I think that most games probably use the short int value, pretty much just short integer. In which case this will show up as 0 because it is far too big for the short integer to handle. But if I changed it to, let's say, 3,707, I think 32,706, that I changed this 8. Now what's going to happen is, I'm sure you can already predict, is that this is going to show up correctly, but this is very important for you to remember the data types. I'm not going to remember it, probably. Well, I don't know. I should remember it, to be honest. All right. We're going to move on here, but it is important for you to remember the integer data type. So because of this, I'm going to mark this page here on my book. We're going to move on. Oh, that's why it was a wrong number. The value. Yep, there you go. So I made a mistake here. What I did was I added one additional number, which made the value like an absurd amount, you know. What I wanted to do is to show you that if you change this by 1, it'll be a negative number. But get back to 7, what's going to happen is that it's going to show us the same number. Anyways, moving on. Okay, I'm going to go AFK for a little bit. It's gonna take about 2 minutes because I need to release the fluids that are building up within my stomach. In other words, I'm gonna go and pee. I will be right back. And then we will go further, and we are going to go into integer of length and width. It is easier to however, to combine. So I'll read the rest soon. Just give me a moment. How long has it been since I've been streaming? Almost 1 hour. But that is nothing. This is just the beginning. Okay. Make sure everything is working fine. Yep, everything is working fine. All right, so we're gonna go ahead and continue on. It says in most programs you will need more than one variable of any given data type. Okay, in most programs you will need more than one variable. Yep. If a program uses two integers, length and width, they could be defined separately like this. Yep. It is easier, however, to combine both variable definitions on one line, int length, width. Find several variables of the same type like this, separating their names with commas. Okay, so it's actually showing you that you could separate different variables, meaning instead of having two words here, what we can do is we could have only one. In this case, we'll do this, right? And then we'll do, instead of just apples, we'll make a comma and we'll do bananas as well. And that's gonna fix it. See that? So now int is also, so in the book it states that in many programs, or in most programs, you will use different type of data types, which means that you will use int literal, you will use, let's say, the long int, or you will use the short int for various things within a program. So because of this, they've made it so that it is easier to just have like one, instead of like writing int bananas and then int peaches and then int strawberries, etc., etc. So with that said, we're gonna move on, and we are gonna go to the example that they're showing. And the example basically shows how to use the commas properly, which we've already done here, so we understand it. There's really nothing else to be said. That aspect. All right, moving on. Plus plus numeric literal is an integer not written with a decimal point. Fits within the range of an integer. Then the numeric literal is treated as an integer. Numeric literal that is treated as an integer is called an integer literal. Yes, we've already said it many times before. I understand it, so let's stop. Okay. It's actually using. Sorry, I'm just. Then I'll put some information out. Plus plus allows you to force an integer literal to be stored as a long integer by placing letter L at the end of the number. Here's an example. Long amount. Right. So there is a tip. The tip says when writing long integer literals or long integer literals, you can either in uppercase or lowercase l because the lowercase l looks like a number 1, you should always use the case l. Programmers commonly express values in numbers other than decimal or base 10. Hexadecimal, base 16, octal, base 8 are popular because they make certain programming tasks more convenient than decimal numbers. By default, C++ assumes that all integer literals are expressed in decimal. You express hexadecimal numbers by placing 0x in front of them. This is 0x, not 0x. Here is how the hexadecimal number F4 would be expressed in C. 0x F4. So this is a hexadecimal. How it is expressed here. Octal numbers must be preceded by a 0, not O. For example, the octal 31 would be written as 031. Right? You will not be writing programs for some time that require this type of manipulation. It is important, however, that you understand this material. Good programmers should develop the skills for reading other people's source code. You may find yourself reading programs that use items like long integer, hexadecimal, or octal literals. Which of the following are... Okay, so this I cannot show you, but there's a checkpoint thing here in which it basically makes sure that you understood most of the content that we've covered in chapter 2, section number 6. So it says, which of the following are illegal variable names and why? Now it has these. All right, we're just going to make a new. I don't have to do. So it says, which of the following are, let me write it down. Following are illegal variable names. Why? Okay, so this is the question that it's asking. Now, we actually put another end line here so that way it's not all messed up. Okay, so since that is the case, it has these choices here, which is 99 bottles, July 97. I'm gonna skip a couple because I know. Wait. Okay, so the question asks which of the following are illegal variable names and why. This is not an illegal variable name. This can work. Like for example, let's say that I wanted to change apples to X, apples to X, apples to X. Now, if I do that, it's still gonna work, as you could see. So that's gonna work regardless of what I named this integer. So, sorry. So we know that this is correct. So this is not illegal. This is, however, illegal because you cannot put an integer in front of the variable. So 9 apples, 9 apples, 9 apples, not gonna work. Okay, so now we know that this will not work because of that. This will not work because you can only have letters, digits, and underscores. that this works, this works, this works, and this will not work. Like for example, if I did apples and whatever, you know. So this is like a review of the chapter that we did. So it's just to show you that these not work. So when you're coding, you need to remember these. If you don't, then you will have a problem. So the first question is answered, and these two you cannot use because of the reasons I explained. We're gonna move on to other stuff. Is the variable name sales the same as sales? Why or why not? So the question is asking, is the variable name sales is the same as sales? Why or why not? Dash. Okay. So is the variable, so let's show it to you. So and the answer to that is it's, let's figure it out though. One sec here. Because I don't actually remember. Out. Works. Everything to sales and sales. Go. Now we run it. We're actually going to change this number to maybe 5. Difference instead of having the same number. Yeah. So as I said, it was the same. It is the same. So with that said, it is the same because change. Well, it's not the same. Well, I don't know. The variable name sales is the same as this. Fudge. Is the variable name sales the same as sales? Why or why not? Is because I don't know how to answer this question to be. I mean, it should be the same. It's not the same. If it was the same, it would error out and it would spit out the same number. It didn't, did it? I don't know. I don't know the answer. All right, let me ask a person that knows how to do this properly, who is called Daniel. Daniel? All right, let's see if Daniel knows the answer. He might be there, he might not. So we're going to move on and go into refer to the data types listed in table 2-6 for these questions. So they don't expect me to remember. If a variable needs to hold numbers in range 32 to 6000, what type of data type would be best? And the answer to that question is short integer. So it is different. All right. All right, so for the first questions answered short and integers, the second one is basically you just refer to this for the numbers, just compare the numbers, and then you're like, okay, so this is fine. So for the next one, it is going to be is negative 40,000 and 40,000 going to be integer. Can't use unsigned short integer because it does not go into a negative number. Okay, so moving on. On any computer, which data type uses more memory? An integer or an unsigned integer? That is a good question. I will ask Daniel. the computer, which data type uses memory? Sorry, everything uses integer or an unsigned. All right. So Daniel should probably know the answer. Master of C++. So he should show it to me. Um, I should link him the hour and 10 minutes. Total peak was 3. So 3 people watched my stream and watched me do terrible at learning programming. But the way things are, you know. All right, so the last question I could not answer, so I got 2 out of 2, so which is 50%. But we'll find out soon. Signed int and unsigned int should have the same. Okay, all right. They have this, so that's a trick question then, is it? All right. Moving on. To what? Character data. Okay, so we are moving on to another type of data type. There are multiple types from the, which means that the ones that we did was the data type. Sure to double check here. Yeah. So the one that we looked at was the integer data type, which deals with numbers. Numbers like this. The one that we're going into right now is called the. It's called the character data type. Oh no no. I was responding to a previous comment. It says that there is no delay on the stream, but that's kind of crazy. I don't know if that's true. Okay, so character data type. The character data type is used to store individual characters. A variable of character data type can hold one character at a time. Here's an example of how you might declare a character variable or a char variable. Okay, so for this, I'm actually going to change it up here. So I'm gonna save this. I'm actually gonna copy most of other commenters saying that this was apparently Daniel can't watch that. That's fine. So 2.6, chapter 2.6. So copy and save this as. So now I'm gonna copy everything and one project. First, I'm gonna close this. character to 7, I guess. Data types. Not sure why you uncheck. Go ahead and start writing new. Now we're going into a different code here. So what I'm gonna do is I'm actually gonna erase this one because this deals with integers, but we're going into the character data type, which means I am going to change our letter. I don't know. I'm not gonna explain this yet because I don't know it yet, but write this down because understanding it, it'll be easier for me to output that to you if it's already written. Out. There we go. Okay, so all right. So sorry, I'm just Daniel is a friend of mine who is proficient in coding in C++ and coding in other languages, and so he can help me with some of the stuff that I will be writing for my programming class. So with that said, let's see here, character letter. So what this is telling me is that the character data type is used to store individual characters. Okay, so this is used to store okay. So character, once again, so this is the character data type. The character data type is used to store individual characters. A variable of the character data type can hold only one character at a time. Here's an example of how you might declare a character variable. Character letter. This statement, which is this one right here, this statement assigns the character G. This statement declares a character variable named letter, which can store one character. Character literals are enclosed in single quotation marks. Here's an example of showing how we assign a character to a letter variable. Okay, so we have the statement assigned. Sorry, this statement. That's it. This one. Yeah. So this statement assigns the character A to the letter variable. Letter equals A now. Because character variables can hold only one character, they are not compatible with strings. For example, you cannot assign a string to a character variable. Even if the string contains only one character, thus the following statement, for example, will not compile because it attempts to assign a string literal to a character variable. I see. So you cannot do something like this whenever you are using the character database. Okay, you have to do it like you can't do it like this. It's not gonna work. Say, whoa, what are you doing? Are you mixing these strings with? Sorry, what are you doing? Are you mixing these literals to a character variable? So you say no, I'm not. I'm doing the work properly. So this should display is the letter A and B there. Okay, so moving on. It is important that you do not confuse character literals, which are enclosed in single quotation marks, literals, which are enclosed in double quotation. I'm not sure why would you use literals, but I don't know. Anyways, program 2-12, which is this one here, shows an example program that works with characters. This program works with characters in IOStream. Okay, include IOStream is still there. I don't actually like the database stuff is very alien to me. I don't necessarily know um, what exactly this stuff does, but when I speak Daniel at a later time, I'll probably figure that type of stuff out. So, but for now, I'm not gonna actually stream that. I'll probably stream that at a later time to explain what I did and how we came to that conclusion and stuff like that. But for now, it's just gonna be just a basic book stuff. I'll go deeper into it as we go further along. So, um, with that said, although the char data type is used for storing characters, it is actually an integer data type. Typically uses 1 byte of memory. The size is system dependent. On some systems, the char data type is larger than. The reason an integer data type is used to store characters is because the characters are internally represented by numbers. So basically what it's saying is that if this was, let's say, 63 and this was 64, it's still going to show up as A and B. Oh, sorry, I am wrong. I don't know what the hell's. Ah, don't listen to me. Okay. Okay, I don't. Okay. This should work. Oh. It's not. Oh, this is not what I want. What is happening to this? It worked fine, but it's not. Maybe it's because of the additional library I have. Let's say I just use the stuff that is telling me, which IOStream and using a int our letter, which our data type letter is 65, which equals to A, 66, which equals to B. Out letter, yeah. Everything looks fine. But what is happening? Why does it say 5 and 6? That is my question. Very weird. Um, letters, letter A. Okay, so maybe Daniel knows. Oh, that's why. See, that makes sense. And this should now turn in. There we go. Okay, so what I just learned is that when you are using the char data type with numbers, you don't put the single quotation mark, not a character. All right. So a char is an integer, not a character. See, okay, so a char and a character are different things. I've been calling char a character, but it's not. See, okay, that is good to know. Okay, huh. All right. So moving on to, I still don't know when I'm going to be using the char data type though, but that eventually I will be using. I need to make sure that when I am numbers, to not put these numbers in. That's going to mess it up. Okay, so moving on. Skip around here. So just to tell you why this happens is because the number 65 in the memory is always going to be A. Number 66 is going to be B, the number 67 is going to be C, the number 68 is going to be D, and then etc., 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 as it goes further and further. Okay, so which means that number 64 will be something different. Curious to see what. So that symbol is that's good to know. Okay, so moving on. Difference between string literals and character literals. That is what I wanted to know. It is important that you do not confuse character literals with string literals. Strings, which are a series of characters stored in consecutive memory locations, can be virtually any length. This means that there must be some way for the program to know how long a string is. All symbol. Okay. That a processor can have. Uh, it is important that you do not confuse character literals with string literals. Strings, which are a series of characters stored in consecutive memory locations, can be virtually any length. Okay. This means that there must be some way for the program to know how long a string. C++ an extra byte is appended to the end of string literals when they are stored in memory. This last byte, the number 0, is stored. It is called the null terminator or null character. It marks the end of a string. See, don't confuse the null terminator with the character. Look at Appendix B. You'll see that ASCII code 48 corresponds to the left or to the character 0. So, whereas the null terminator is the same as ASCII code 0. If you want to print the character 0 on the screen, ASCII code 48. Want to mark the end of a string, however, use ASCII. Let's take a look at an example of how a string literal is stored in memory. I'm not understanding this right now. A moment has to go through, but I think this stuff is important though, because this is an entirely different uh, data type than the one that we learned before, which was the integer data type. So what I'm curious to know is when do you use a character data or a char data type when integer data type, and what's the usefulness of using the char data type? Uh, plus automatically places a null terminator at the end of string literals. So now let's compare the way a string in a char is are stored. Suppose that you have blah blah. Okay, a is stored as a 0. Okay, let's just ask Daniel on. Oh, okay. Oh, oh. That is okay. I'm gonna ask Daniel on when do you use? I actually, yeah. What? Yeah, actually, that should be one. Okay, Daniel should hopefully respond soon, and then I will know the answer to that. As I go further along here, one final topic about characters should be discussed. You have learned that some strings look like a single character but really aren't. It is possible to have a character that looks like a string. A good example is the new line character /n /n, sorry. Although it is represented by two characters, a slash and an and, it is internally represented as one character. In fact, all escape sequences internally are just one byte. Okay. Program 2-4 shows the use of /n as a character literal. Closed in single. You refer to ASCII chart in appendix B, you will see that ASCII code 10 is the line feed character. That is the code C++ uses for new line characters. Okay. Mustering more one. I still don't know why you would use the char data. Like, what is the purpose when you can just use a string literal? That is the question that must be answered somehow, some way. Let's review some important points regarding characters and strings. Printable characters are internally represented by numeric codes. Most computers use ASCII codes for this purpose. Characters normally occupy a single byte. Strings are consecutive sequences of characters that occupy consecutive bytes of memory. Literals are always stored in memory with a null terminator at the end. This character literals are enclosed in single. String literals are enclosed in double quotation. Escape sequences such as /n are stored internally as single characters. Small numbers as in 0 to 255 or characters / letters. Um, All right, let's see what Daniel has to say to that question. That way it's a bit better. Okay, all right, so moving on. Maybe the reason why you use char database is to, the only reason why you probably use it is to save some memory. If you're using these small numbers or character sets, you would use char data type. At least that's what I'm getting from it, but whatever the answer is from Daniel will answer this question. All right, so moving on. The C++ string class is the next section in chapter 2. Standard C++ provides a special data type for storing and working with strings. Normal basic C string literals are chars. I think characters that is chars, you know. It's kind of weird calling it chars when you can call it characters. I don't know. More water, so grab some more. Okay. So we're moving on to the C++ string class from the looks of it, and string class. The first step in using the string class is to include this, to use this, which is include, is to include the character. Okay, all right. Because a char variable can store only one character in its memory location, another data type is needed for a variable able to hold an entire string. Although C++ does not have a built-in data type able to do this, standard C++ provides something called string class that allows a programmer to create a string type variable. In modern C compilers, you have string literals for wider character sets that use more than 8-bit. Okay. All right. Normal basic C. Oh, okay. See, it's just telling me that the char data type is, I guess, basically this letters. Anyways, I don't think it's as important, so I'm gonna move on. It is probably important, but not as important as the other stuff here. So, okay, using the string class. The first step in using the string class is to include, which I have highlighted here, is to include the string header file. This is accomplished with the following preprocessor directive. Well, it's not necessarily homework, it's just me, but I think that's a better way to explain why I cannot. So, um, include string. So this is called a string. This is a string. Okay. String class. Okay. It's called a string class. It's not that. Yeah, it's not really that important. I'm not gonna make it in a comment here. The next step to define a string type variable called a string object. Defining a string object is similar to defining a variable of a primitive type. For example, the following statement defines a string object named movie title. String movie title. Assign string literal to movie title with the assignment operator. Title equals Wheels of Fury. You can see out to display the value of movie title object as shown in the next. Program 2-15 is a complete program that demonstrates the preceding statements. Okay. All right. So we're actually done with the chart data type. They didn't go further into it, but that's all you need to understand is that normal basic C string literals are characters. So and char data type is used for small numbers or characters / letters from 8-bit character sets like ASCII or the lower UTF-8 characters. I know what this means. I know what this means. I know what this means. So, not that important because they didn't even cover it in an extensive form. We're going to move on here and I'm going to write some new code. Do that, and we're going to write the next part of the code here, which I'm going to write, and then we'll go step by step in understanding it. And if I don't understand something, I have Daniel, whom is helping me with understanding some parts that I don't get. So this is required for a string class, so I'm actually going to. All right, moving on. Thank you, Daniel. I do appreciate it, man. String would be movie title. Title out will be my favorite movie is title. Why is this wrong? Oh. Yep, there we go. Okay, so what does this do? That's my favorite movie is Superman. Okay. Add this. Boom. Done. Now this should look a bit better there, see? Alright, so the example, as you can see, working with string objects is similar to working with variables of other types. Throughout this text, we will continue to discuss string class features and now, in the previous sections, we were able to get this information already. Not sure why would we want the string to be title and write additional code when we just write movie title equals this. Then we just change that to what? Why are we even adding additional stuff there? Because we could get the same thing without even using string library. For example, if we just remove the string here, check. Okay. Oh, okay. That's because we need to assign the string to a thing. So the reason why we have the string there is because so now this word basically means, but if we wanted to do it in a different way, we would have to use int, and then we would use movie title, which is the wrong way to do it, which is a reason why the string command is there. That way we can change the words into different words. But then why not just write my favorite movie is Superman instead of like writing the string? But maybe it is because I'm sure it's gonna explain more later, but I understand why this is used. Okay, so the string is used like the int number, the integer number, the one that we did before, is to assign the variables into numbers, okay? Now the string command is basically doing the same type of thing, but instead of it assigning it into a number, it is assigning it into a different name or a different variable. At least that's what I'm seeing here. So that is the reason why they use the string string library. Okay, so with that said, we are going to go through some checkpoints here because we have reached another checkpoint according to the book. What are the ASCII codes for the following characters? CFW. So if you go back to the ASCII ASCII, I think it's called. Yeah, ASCII library. We know that the letter C is number 67, which means that the letter F is probably gonna be around 70, and the letter W is gonna be around maybe like 80 or something. So, which of the following is a letter literal? A letter literal. So sorry. It is asking me which of the following is a character literal. Now, no. Now we know. Sorry. One sec. Now we know that the. Okay, so let me ask you, if you. Anyways, which one is a character literal here? Is this a character literal or is this a character literal? You have 3 seconds, 2 seconds, 1 second, over. This is a character literal. You cannot have this because the system will be like, what are you doing? This is a string literal. This is a character. This is a child literal, etc., etc., etc. So you cannot use double quotation marks whenever you are dealing with the character literal. Okay, you always need to use the single quotation mark. So that is done. Let's move on to the next question if it's important. Assuming that the character data type uses 1 byte of memory, how many bytes do the following? It's gonna be 1 1 1 2 3 4 5 and then 1. That's, yeah, sorry, it's easy question to answer. Write a program that has the following variables: first, middle, and last. Following character variables, okay? First, middle, and last. Store your initials in these variables, then display them on the screen. Okay. Now we are writing a program. Just great, I guess. Kind of. Sort of. Maybe. This is the first program that I'm not just copying from the. How this goes. Alright, so write a program that has the following character variables. First, okay, so we're using the character data type, which I don't actually. Our letter, right? So. Okay, the picture quality is fine, but the audio. Okay, I can fix that right now. 1 second here. Easily fix it. All right. I'll go a little bit lower here. Okay, all right. This should be fine. It's just that I have my settings set up so that way, if I'm not doing much, like it's not gonna pick up my noise. Now, like it's gonna pick up majority of the things that I do. In this case, a turning of a page, it will pick up here. See? So, it should be fixed now. Thank you, Daniel. Okay, so Charles Letter. Well, what I'm doing now is I'm writing a program that has the following characters: first, middle, and last. Store your initials in these variables, then to display them on the screen. Okay, so let's do. I don't actually remember. Okay. Letter Atsu. Too many no, I don't understand this then. Now if I put A there, it'll work, but no. It is asking me to use the character variables first, middle, and last. Store your initials in these variables, then display them on the screen. Okay, so this is what it's asking me. I don't know how to do this. Write a program that has the following character variables: first, middle, and last. Store your initials in these variables and then display them on the screen. Oh. Okay, so this is what it's asking me to do. And now the problem is that I don't know how to use the character data type to put more than one letter. Like I could do something like this in which I could have uh, char, letter, what am I doing? Okay, letter equals B, oh sorry, T, right. Okay, let's see what does this display then, I guess. It displays nothing. Nothing. Why? I everything is breaking. Nothing is going good. It's not good. Not good at all. I need to reference back to this, I guess. Oh, I have figured it out. But this probably is not the way to actually do this. But I'm going to do it anyways. It's gonna take a while, I guess. Out letter, and then I will output this. See out letter, and then I do letter equals s, and then see out letter. If there's a better way, please let me know. Because I don't think this is how they want me to do this. But maybe they do, because they're evil. Letter, and then letter equals u, and then see out letter, and L. and then I would assign additional stuff, like I would write mon. So then I would do letter M, cout letter equals O, cout letter, and then N, cout letter. There we go. You have only one character variable letter. They want you to have 3 variables. Let me just test this out before. You have only one character variable letter. They want you to have 3. I think I know what you're saying. So what if I did this then? Character. But instead of doing letter, let's just do Atsu. Sorry, Atsu. Then let's do the next one, Mon. Okay, Atsu Mon. Which means all of this work that I've just done, useless. Gone. Even though that worked out fine. Let's see. That is fine, Daniel. Do not worry about it. All right. So I have 2 characters there. Even like this is what I have. Since there's a 30-second delay, I'll just show you this. I could have a third one. Okay, so I defined 2 of the characters, which is Atsu and Mon. Now the question is, how do I display them using the character database? Oh, store your initials in these variables and then display them on the screen. Why did I do all that work? Why? That was I should have like read the question a lot better. I didn't, and that is why I had to do more work than necessary. That's just that's pretty bad. That is pretty bad. And mon equals b. What? No! How? How did I mess this up? Where did it go wrong? Oh, right. I didn't like output the the stuff. My first program sucks. I'm sorry. All right, and then I would end line, and then the next one I would do cout mon, and then I would do end line, and then end it. There we go, and that should do it. This should work fine. They should display the characters HB. There we go. Done. All right, so that worked out fine, kind of, not really. I should probably format this. I know there is a way to do it. I just don't remember how to. Bookmark, call, hierarchy. I don't remember how to format this, but there is a way to like make it so that way this isn't going off the screen. I just don't remember how to do it. But anyways, this is what the question is asking me. The question asked me, write a program that has the following character variables: first, middle, last. So basically what it actually wanted me to do is to do this first. I'll just do first and L last. But what it wanted me to do is to have this being first and this being last. So then I would just need to change all of this to this. There we go. Last. Okay, and now the program should work fine here. In this case, it'll be HB. Okay, so it asked me to do this and then store your initials in these variables and then display them on the screen. And that is exactly what it did. Thanks to Daniel, I got a little bit of hint there, which helped me understand this stuff, which worked out fine. So you can store the, I guess the character literals to one-letter variables. Okay, so that's that. So that is done. That question is completed. That was great, and it made me do some stuff that it didn't show me how to do. It just asked me to do it, and there it is. Thank you. Okay, moving on. What is wrong with the following program? So basically it is asking me what is wrong with the following program, what is, sorry, I'll just write it down, with the following program statement. What? Really? Wait a minute. No, it should show. Wait a minute. Sorry, I should not have Twitch chat there. Okay, that should be much better. I'm not sure what you meant by the program output is obscured by your face on the screen. Let me. You can. Oh, that's why. I see. Oh, right. Thank you. That should have not been happening at all there actually. Uh, okay. Yeah, so I will actually move it back whenever I do this. Sorry, I didn't even realize that that would happen. So that was kind of weird. All right, but I have changed it now. So now I know that whenever I build it, I will have to move the screen down so that way you can see it. Sorry about that. I had no idea that it was actually doing that. So like the entire time I was showing examples, but like it wouldn't show you anything. It'll just show this like command prompt box and that's it. So, okay, so that's the example how it was done and it worked fine. Thank you, Daniel. Like I had no idea. Wow, it's kind of crazy. Okay, so the question is asking what is wrong with the following program statement. Now, the program statement states this. What is wrong with this is that it has the string like it has the double quotation marks instead of having the single quotation marks, which is the reason why this is wrong. Which is now this is correct because it is a character variable. It is not a string variable. So with that said, we're going to move on to the next question. What header file must you include in order to use the string objects? This is the header file that we must use to include the string objects, which is include string, which is the library of string. Okay, so moving on. Write a program that stores your name at, oh, nope, not writing that stuff. We'll change it to something else. But it's asking me to write a program that stores your name, address, and phone number in 3 separate string objects. Display the contents of the string objects on the screen. Okay, all right. So it is asking me to use this that I learned, the string library, to write a program and basically show my name, address, and phone number in 3 separate string objects. So then what we can do is we can do string, and we can name this name, string, and we can name this address, And we can do one more string here. Wait a minute. Oh, maybe that's why. Aha, okay, alright. For a second there I thought, what is happening? Okay. And phone number. What? Yeah, I have that. What are you talking about? Ah, well, phone. Okay. Alright, whatever. Moving on. Okay, so now that we have these three, what we can do is we could write cout. I am, oh, sorry. I am Atsuo. Wait, I am, I don't remember how to do this. All right, what I can do is change the name to, whoa. I am such a beginner at this thing that it's just insane. Insane? Insane. Yeah, there we go. 555 Devil Road. I don't know. Whatever. Oh, okay. All right. I cannot start with an integer. Remember? Yeah, I remember now. So it's gonna be. Uh, Wait a minute. I, I know that I cannot start with integers, so but it is asking me to name my address. So I guess I can do 55th Devil Road or whatever. I know. Use underscores. Boom. Problem fixed. I am cout, and then I'll do atsu. Oh, right. I forgot to end this. There. And then I'll just do end line. Cout. I live. Oh, I love. I live at I'm probably doing this wrong, but I just want to figure this out. So end line, and then cout. My phone number is. I have a phone. Okay, this should work. I live at, nope. That is not how you do this. I messed up somewhere. I don't know where. Right. I didn't define what Atsu is. That's why. So if I actually put just name here, if I just put some address here, and the phone is phone, like this will be a bit different because I didn't define what the Atsu meant. So what I'm gonna do is I'm gonna put Atsu, wait, sorry, name equals Atsu. And then I'm going to define address. Sorry, I actually need to learn to end them with this. Address equals 555 Devil Monster Hunter 5. I don't know. Road. Devil Monster Hunter 5. Phone equals 1, 2, 3. Wait. 1, 2, 3. My phone number, right. So I need to change this as well. my phone number is phone. I live at, yep, I am, yep, okay. 4567890. And that should do it. Now I just need to change these to name, address, and phone, which is already done. Okay, so this should work fine now. Great. The only thing missing is just the dot, or I guess the proper sentence structure, which means that what I can do to fix it is just do dot /n and copy this, paste it here, and we're done. So now it's properly fixed, everything is good. Cool. All right, so I just created 2 programs that the book specified me to do, and in one of them Daniel definitely helped, thank you. And on the second one, I figured it out, so things worked out fine. But you don't really have to do it like this though, but it just makes it more complicated. But I guess as a program further, these things are going to be really, really useful. Actually, I could use, if I'm using the same information here for multiple lines, like I could just do the name stuff instead of like just like writing it down again and again. So I can see some useful applications for it. But that's it. So the question was this before I go on. Well, I don't want to write the question, it is too long. But basically, that's the program that the book asked me to do. What this program does is it tells you my alias, it tells you where I live at, and it tells you my phone number. And that's it. We haven't gotten into the cin part of C++ programming yet, so that's going to be a bit different. Let's see, how long have I been? Wow, 2 hours so far. I see. All right. So with that said, we're going to move on, and we are going to head to float point data types. Now, float points is the stuff that I don't understand yet, so this is going to be interesting. Concept is that float point background has police sounds. Okay. I'm going to mute the microphone. Okay, and we are back. All of the noises appear to be gone. So the concept with float point data types are used to define variables that can hold real numbers. Whole numbers are not adequate for many jobs. If you are writing a program that works with dollar amounts or precise measurements, you need a data type that allows fractional values. In programming terms, these are called float point numbers. So basically, fractional values are float point numbers. Internally, floating point numbers are stored in manner similar to scientific notation. If you don't know what scientific notation is, It is basically a way for the scientists to display large numbers. Let's say that you wanted to write a number like this. Instead of writing all of that number, well, it's much bigger most of the time. You could just write 48, I don't know, thinking, sorry, 48,000, 4,800, whatever. Something like this. To the 10th to the, I don't know, 2,900. And this basically tells you that this is a huge number, pretty much. So instead of writing a huge number like this, you basically do a smaller amount. So this means 10th to the 2,930 power, etc., etc. And yeah, anyways, it's pretty basic stuff. So I'm sure that if you're into programming right now, you already know about these scientific notations. So me explaining that is, you know, it's not gonna work. Anyways, moving on. Internally, floating point numbers are stored in a manner similar to scientific notation. Take the number 47,281.97. In scientific notation, this number is 4.728197. Okay, blah 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 blah. Doesn't matter. The first part of the number is called Mantissa is multiplied by the power of 10. Yeah, computers typically use E notation. Okay, so this is the important part here, which is computers typically use E notation to represent floating point values. In E notation, the number 47,281 and 97 cents would be 4.728197 E4. The part of the number before E is the mantissa, and the part after the E is the power of 10. So, okay. When a floating point number is stored in memory, it is stored as mantissa and the power of 10. Okay? Table shows blah blah. Basically, what it's saying is when the computer is using the scientific notation, so let's say that there is a scientific notation for number 47247, 2.4791 times 10 to the second power. This would be shown by the computer as 2.4791E2. Now how you can differentiate that is by saying, okay, so it has the same values here, just like the scientific notation, but instead of it being times 10 to the second power, it just says E2 to 2. E basically is times 10, and then 2 is to the second power. So what about when they're negatives? When they're negatives, it'll be like, so let's say that the scientific notation is 7.2 10 to the negative 4 power. Okay, so this would be displayed by the computer as, is it? Yeah, okay, sorry. This would be explained by the computer as 7.2 e to the negative 4 power. Basically, that's that. So same thing, except the times 10 to the power is replaced with e, and then it's negative 4. And that's it. Simple. Okay, moving on. In C++, there are three data types that can represent floating point numbers. They are float, double, and long double. The float data type is considered single precision. The double data type is usually twice as big as float, so it is considered double precision. As you probably guessed, the long double is intended to be larger than the double. Of course, the exact sizes of these data types are dependent on the computer you are using. The only guarantees are a double is at least as big as a float, a long double is at least as big as a double. Table 2-6 shows the blah blah blah. Sorry, I'm just reading through this, and then I'll probably say something. On all machines, variables of the float, double, and long double data types can store positive or negative numbers, which is the reason why there are no unsigned floating point data types. The majority of the time when you're using an unsigned data type, you cannot go negative. But when you're using a signed one, you can go negative. So that's the difference. Okay. So three of them, I guess this is important because you will be using this quite a bit whenever you want to have accurate precision with your numbers. So the three are float, double, and long double, which we will most likely see in the examples that the book lists us with. So moving on, there is a program example here which shows you how this works, which means that I will show you how this works. So we're actually gonna go ahead and remove majority of the content that we just wrote, and we're gonna start from the beginning, which is float distance, and then double mass. Okay, and then I will explain more as I learn more about it, so I bet it's easier for you to understand. 1.45979 E11. Oh, sorry. So remember, as I said before, the E stands for times 10 to the 11th power. So, and since it's not E minus 11 or E negative 11, I'm gonna mute the mic one second. Oh, actually, it's not that bad according to Daniel, so I'm not gonna mute it, but I'm gonna keep on talking over it. Since it doesn't have a negative in between, this means that E, it's not times to the negative power pretty much. So we're gonna move on here, and we're gonna go on mass. So mass will equal, so mass's value will double. So double is basically the double of float, and then long double is the double of double. Sorry, it feels like I'm trying to confuse you, so I'll go step by step soon here. Anyway, so I'm going to enter the mass here, 1.989 e to the 30th power, okay? And then what I'm going to do is I'm going to output it to command prompt, which will state that the sun is, so then we're gonna get the distance here, distance meters away. I should probably end line it, but instead of doing that, what I'm gonna do is I'm just gonna do this. Okay, and then the next one that I need to output is the moon. Okay, the sun's. Okay, the sun's. I don't know if that's an error. Let's just write it as the book says it, and then I'll go from there, I guess. Mass is mass kilograms. Okay. Also, we need to capitalize the sun because it is a planet. All right. And now we are going to run the program to see what it actually does. Okay. Is this correct? Okay, that's one. Yeah, it is correct. So That's great. So we just displayed the numbers that I assigned to, and that's pretty much it. I didn't really do anything else besides that. You can also express float. Okay, so since I wrote this down, so basically, I don't think this is a good example to explain the float and double, to be honest, because what it's basically doing is just showing the values on the command prompt. I don't think this is a good example because I don't really understand what it's trying to achieve, because I can do the same thing with other data types as well. So I don't, you know. Okay. You can also express floating point literals in decimal notation. The literal could be written as, I'm not going to say the number. Obviously, the E notation is more convenient for lengthy numbers, but for numbers like 47.39, decimal notation is preferable to 4.79 E1. Yeah, all of the following, okay, all right. Okay. All right, you should probably notice that when I did this, right? When I did this, the E's were actually capitalized in the coding, but when it's outputting it, the E is lowercase. It's not uppercase, and that's because that's how the C++ tends to display that. At least that's what I gathered from it. So, with that said, let us move on to other stuff. This is important, I think. Float point literals are normally stored in memory as doubles, but remember, C++ provides tools for handling just about any situation. Just in case you need to force a literal to be stored as float, you can append the letter F or F to the end of it. For example, the following literals can be stored as floats. I see. Okay. Assigning floating point values to integer variables. When a floating point value is assigned to an integer variable, the fractional part of the value, the part after the decimal, is discarded. For example, look at the following. So basically, what it's saying is that when you are storing stuff like in integer forms, it's going to discard the decimal value, or it's going to discard the numbers after the decimal point. Like, for example, let's say this is blah 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 dot 58. It's if you use an integer number to actually display that, it's going to discard this part, and it's just going to display this. I can show it to you, but I think writing it down will take a lot of time. It's better to just explain it, which is the reason why. So when you want the stuff after the decimal point, you need to use point float point numbers, is it? Well, what is it? Okay, float point literals, because you need to use that in order to keep the rest of the stuff, which means that in a lot of the in a lot of financial applications, they use the float point numbers instead of the integer numbers, because that gives them the correct estimate instead of them just having just this number. They want the entire thing, which means that set precision is also an important part. Anyways, we're gonna move on. Just give me a second. Well, looks like that Daniel has something to say. Okay. This code attempts to assign the floating point value 7.5 to the integer variable number. As a result, the value 7 will be assigned to number. With the fractional part discarded, when the part is discarded, it is said to be truncated. Okay, so it's the term is called truncated. I think Daniel is typing something to me, so as soon as he types it, I will read it out. Never use floating for money. Oh, okay. Do not use floating for money. I was wrong. Sorry. As we go further, I suppose we will find out why. All right. Do not use float point numbers for money. It is a bad thing. I don't know why yet, but we will find out. This code attempts to define blah blah blah. Yeah. Assigning a floating point variable to an integer variable has the same effect. All right, so there is a note here regarding them. When a floating point value is truncated, which means that the value to the right side of the decimal point is discarded, it is not rounded. So once again, when a floating point value is truncated, it is not rounded. Assigning the value 7.9 to an integer variable will result in the 7 value being stored in the variable, which means that if the when the floating point value is truncated, so let's say that you had the value of 7.9, it's not going to round up to the closest number, because if you round it up it would say 8.0 or something, right? But no, it is going to just keep the 7. It's going to just keep the 7 instead of rounding up or rounding down the number. Okay, so that's that. All right, so moving on. There's a warning here. This is a new one because I haven't actually seen the warning symbol before. It says floating point variables can hold a much larger range of values than integer variables can. If a floating point value is being stored in an integer variable and the whole part of the value, the part before the decimal point, is too large for the integer variable, an invalid value will be stored in the integer variable. Oh, okay. So basically what it's saying is that when you are mixing float point variables with integer variables, since float point variables can go for much further number wise than the integer variable can, what ends up happening is that you will get the wrong number when you are writing a program like that. Maybe it will demonstrate it, but so far I haven't actually seen that happen. But it makes sense, because if the float point can hold more data, then that means that the integer value, and since the integer value can hold less data, and when you combine them together and you have a data that the integer value cannot handle but the float point can, what will end up happening is that you will get a wrong answer, most likely. So I guess the concept is a bit difficult to explain without writing an example. but I don't know how to write the example right now. Perhaps when I'm more proficient in the language, I may go back to it and write it to explain it better, but right now, that's the explanation. So, moving on. Now, chapter 2, section 9 is completed. The next is chapter 2, section 10, which is the bool data type. So, chapter 2 is covering the various data types that is available in the C++ language. Boolean variables are set to either true or false. Expressions that have a true or false value are called Boolean expressions, named in the honor of English mathematician George Boole, who lived in the 1800s. Well, it's a pretty long time. The bool data type allows you to create small integer variables that are suitable for holding true or false values. Program 2-17 demonstrates the definition and assignment of a bool variable. All right, so let's learn about bool variables. That's another data type. There's so many data types, it's kind of crazy. Okay, so bool value. Okay, moving on. Let's go more further. So I'm gonna write the program and then I will try to understand it. Well, I will understand it because there is no trying. I have no choice but to understand it. So, and Daniel is there to assist me if I am having difficulty understanding it. Whoa, sorry. Value. Okay. Almost done. And see out. Okay, so that's the program. This is using the bool data type, which basically handles true and false stuff apparently. All right, so let's see what it does. What it should do is show 1 and 2, yeah, which it did. I also removed the system pause, which was pretty bad. So let me add that in so you can see it. All right, I need to also end the line there. So 1 and 0. That's the bool value, which is located here. So with that said, we're going to move on and read more. As you can see from the program output, the value true is represented in memory by the letter 1. So as you can see, this is bool value true, and the true value is represented as 1. And false is represented by 0. So false, which is this one, which is outputting in the second line, is represented by 0. You will not be using bool variables until chapter 4. Chapter 4 is a long time. Yeah, okay. However, so just so you remember, they are useful for evaluating conditions that are either true or false. Okay, all right. That works for me. We're moving on to determining the size of a data type. The concept is that the size of operator may be used to determine the size of a data type on any system. So we're learning a new command here, which is called the size of operator. And it is used to determine the size of a data type on any system. So if you want to find the data type on your computer, you would need to use that operator. A special operator called sizeof will report the number of bytes of memory used by any data type or variable. Program 2-2 illustrates its use. The first line that uses the operator is line 10. Okay. So let's do that. Let's write the program really quick here. Just give me a second. Okay. All right. Here we go. So long double apple. And now we're going to start kind of writing a couple of things here. The book is not telling me to write it like this, but I just want to try it out just to see how what it looks like. Okay. All right. So we'll do the first one, and we'll do one more because the example is actually pretty long, and I don't want to write all of that stuff, so I'm gonna just trim it. Can be eaten in size of apple. All right, forgot to. I need to get used to doing this because I keep on messing. I keep on skipping it, and it costs more time. So, okay. So let's. What the hell happened? Oh, that's why. Okay. The program is what was still running. I'm like, what is happening? Why is it doing that? Okay, so showing this. Okay, so the size. So what the program does is that it determines the size of integers, long integers, and long doubles. So what we did was we basically changed the value of apple to long double, and the value of integer and the value of long, which I did not do, but I can do if you want. I should probably just do it just to show you, I guess. See how which would be. I think I won't need to repeat this. The size of a long is size of long bytes, and edit. There. Yes, got it the first time. It's great. So it looks like this. Yeah, show it to you. Integer is 4, long is 4, long double is 8. Okay, that is, I guess, good to know. Moving on. Checkpoint. Okay, we have reached another checkpoint here. How much more is remaining, I wonder? Okay, we're almost done. All right. Yes or no? Is there an unsigned floating point data type? If so, what is it? Was there an unsigned floating data type? I don't think I have actually even discussed that. That's kind of interesting. This is a question for Daniel, because I do not know, but knowing it would be useful. I see. Yeah, I could have sworn that I didn't see any, so that makes sense. Okay. All right. So there is no unsigned floating point data type in C++ programming. Okay, so moving on. I'm sure that Daniel will chime in a bit more, but before that, I'm going to what? Okay, there may be, but typical floating point types, i.e., the ones, or for example, the ones in your Intel and AMD CPUs are always signed. Oh, okay. Okay. All right. That is good to know. So they're always signed. Okay. So in other operating systems that are not Intel and CPU based, there can be unsigned floating data types. All right, that is good to know. But for your and my computer, will always have signed data types, unless we're using something that is not made by, I guess, Intel and AMD. Okay, so moving on. How would the following number in scientific notation be represented in E notation? So what the question is asking me right now, or yeah, what the question is asking me is how would this be translated into will be represented in the E notation. Now, how would this be represented is that it would be something like this, and it would be E17. That's it. Easy. Okay, moving on. Write a program that defines an integer variable named age and a float variable named weight. Store your age and weight as literals in the variables. The program should display these values on the screen in a manner similar to the following. Okay, alright, so I need to write a program now in order to demonstrate my understanding of the subject that I've just learned. So what I'm going to do is I'm going to start writing it. So what it's asking me to do right now is write a program that defines an integer variable named age and a float point. So I should actually just write this down so that way I have something to write upon. Oh, right. Okay, so this is what I need to write, or what I need to do right now is I need to write a program that defines an integer variable named age. Okay, so integer variable named age. So what we need to do is we need to do int age. Okay, all right, and a float variable named weight. So a float variable named weight. Okay. So then store your age and weight as literals in the variables. I don't know what this means. As literals and as variables. The program should display these values on the screen in a manner similar to the following. My age is 26 and my weight is 180. Okay, so let's assign a number to age. So age is going to be 26 and weight is going to be 180. So we're gonna also end these with that. Okay. So now I'm going to do cout my age. All right, sorry. Wow. My age is age. Right. So what I can do is dot. Right. Sorry, I'm messing up here with my code, but things should be normal soon enough. My age is, yeah, and okay. My age is, yeah, and my weight is, I really need to learn to like end my string variables properly because I'm not doing them. Okay. Okay, that should do it. So I'm actually not going to use this cout, so it should be fine. All right, let's build it and let's test it out. Oh, okay. Don't look at that. No. Okay, it should be much, much better. There it is. Oh, sorry. Don't look. No. There. All right, there it is. That's exactly what it asked me to do, which is my age is 26, my age is 26, and my weight is 180 pounds, and my weight is 180 pounds. So there we go. Working fine. All right. We're done with this one. I'm gonna go a little bit faster now instead of going at this slow pace, so that way it works fine. So I know how to use this. I hope that you do too. Is how to assign a specific thing to either an integer or a float value. How to define them, which is this way, and then how to output the stuff on the screen, which is this way, and how to make it properly aligned and how to pause it so that way it works fine. We'll also learn about the get ch command, but that's going to happen at a later time. So with that said, um, I'm going to go ahead and proceed at a much faster pace here. As you have already seen in several examples, a value is stored in a variable with an assignment statement, um, which, for example, the following statement copies the value 12 into variable units sold. Units sold is 12. The equal symbol is the assignment operator. So this is the assignment operator. You cannot write it like this. Like you can't do like 26 equals age. That's not gonna work. So you have to do it always like this. Age equals 26. So you assign the variable and then you assign the number. Okay. So with that said, we're gonna move on. In C++ terminology, the operand on the left side, blah blah blah, is it also explains why the C++ language does this, but yeah, just do it like this and you should be fine. So once again, it's just going through how to assign the integers just to this stuff. So it just continues to repeat it, but we already have learned how to do so multiple times, so we're not going to continuously write more code regarding this because, well, you know, we need to progress faster. All right, declaring variables with the auto keyword. That's different. I will be right back. I must go and release the fluids again. And then we will go with learning about the auto keyword, which should be interesting. All right, be right back. Okay, so let me make sure everything is working properly. Looks like it's picking up my voice. It's yep, everything is working fine. Okay, so it was the auto keyword that we were going to learn about. So let me drink some water. Check how long. Oh, about 3 hours now. It's a pretty long time. But that is nothing. I'll be studying for a lot longer in the coming days. Oh, especially when it comes to mathematics. I think that's going to be interesting. I don't know how I'm going to do it, but I'll figure something out. So yeah. With that said, C++11 introduces an alternative way to define variables using the auto keyword. Okay, can define variables using the auto keyword and an initialization value. Here is an example. Auto amount equals 100. Notice that this statement uses the word auto instead of a data type. The auto keyword tells the compiler to determine the variable's data type from the initialization value. In this example, the following initialization value is 100 as an integer, so amount will be an int variable. Here are examples. Okay, so let me just read through this and then I'll try to explain it. So the auto key word is actually used to define stuff a bit easily, because instead of writing like int age, int etc etc and blah 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 blah, what you can do is you could just do this, which is like auto age, and then you could do auto weight, which is 180, and it will automatically just assign stuff to the integer stuff. So basically it's going to say the same thing, except it just makes it easier, so that way you don't have to tell you don't have to tell the system everything, which is cool. So like if I wanted to do this will turn this into a long value, which I'm not sure what it's going to show, but see. So this will be explained more at a later time according to the book, and it is pretty useful. And I guess as a programmer, you'll be using this a lot when you are dealing with much larger numbers or a lot of numbers or something like that. So we're going to move on to chapter 2, section number 13, which is the scope. A variable's scope is the part of the program that has access to the variable. That's the concept. So I need to see an example. Sorry. See here. Every variable has a scope. The scope of a variable is the part of the program where the variable may be used. The rules that define a variable's scope are complex, and you will only be introduced to the concept here. Okay? In other sections of the book, we will revisit this topic and expand upon it. The first rule of scope you should learn is that a variable cannot be used in any part of the program before the definition. Program 2-20 illustrates this, okay? Oh, okay. So what is showing me here, well, I'll just show it to you here as well so you know what I'm looking at, is that you can't do something like this here. I'll just make a small example, blah, and then you give the value to blah equals mullah, I don't know, but you know, like you can't really, let me put a better example instead of doing it like this. So let's say that I'll do it as value, okay, cout value, okay. Now I haven't really defined value yet, so what it's telling me is that int value equals 100, okay. Now I've given the the string literal a number, okay. So I've given it 100, okay. Is that integer literal? No, yeah, this is integer literal and this is string literal, okay. So I've given it value, but I've given it value on the bottom instead of on the top. So it doesn't know what is happening. Why am I doing this? Like it's saying, okay, so what the hell is this? Like I don't know what are you trying to do? So you always want to make sure to write, to give the word, you know, to give the string literal the integer value first before you output the command. So now it's actually going to show us that it just is 100, see, so which is 100 here. But if we put it on the bottom like I tested it before, what you will see is that it's not going to work because the compiler does not know what the hell is going on. It's not smart enough to do that, I guess, or something, I don't know. Anyways, so you always want to make sure that you define your string literals first before you output the integer literal. I hate saying those words because they're just like so weird, and but I'll get used to it though, most likely. Okay, so that's pretty much what it's showing you is just a scope. It goes further into this, so this is like, I guess, a very basic example. So when I do reach that, I'll, you know, I'll cover it as well. So anyways, arithmetic operators. There are many operators for manipulating numeric values and performing arithmetic operations. C++ offers a multitude of operators for manipulating data. Generally, there are three types of operators: unary, binary, and ternary. These terms reflect the number of operands an operator requires. Unary operators only require a single operand. For example, consider the following expression. So let's consider the following expression, which will be located somewhere here. There we go. Okay. -5 is the following expression. Of course, we understand that this represents the value -5. The literal 5 is preceded by the minus sign. Okay, so basically what it's telling us here is that this programming language uses the order of operations and I know that you guys should already know about it, like as in uh, things in the brackets, such as like left bracket, right bracket go first, and then comes like multiplication and division, and in I think C++, this is division, and then it comes, plus and minus and blah blah, etc., etc. So that's basically what this section number 14 is telling us, is that this programming language uses the order of operations. Uh, what like here, I'll just give an example out here so that way you know exactly what I'm talking about. So let's say that we give values to specific things. Let's say that we actually use string here. Okay, and we're gonna name the string money. Should I use string? I don't know if I should use string. I'll just use string, whatever, doesn't matter. So then, no. Okay. Instead of you using string, what we're gonna do is we're gonna use an integer value, and we're going to name the int money, and we're going to use another one, and we're going to name it work. Okay, so those are the two that we're gonna be using. So what this is telling you is that you could do it like this, like, all right, and we should also use one more integer, and we'll name it uh, uh, free money, free, whatever. I don't really, it's not making much sense. It doesn't make logical sense. So let's say free time, whatever. Okay. All right. So now what we can do is we can assign the values here. So we'll do money equals 20, and we could do work equals 40, and then we could do, sorry, I actually should end these before I continue on. Okay, there we go. And then we can say that free time is money times work. Okay, sorry, money times work. Okay, now then I could output and say I have this much, sorry, one moment. Okay, here we go, free time, and then could just do money, sorry. Okay, so now what this is going to do is that it is going to, well, actually, let me just show it to you, and then you could see it. So basically what this did is that so I assigned an integer value to money, work, and free time. Okay, so I assigned the money value to 20, I assigned the work value to 40, and I assigned free time to money times work. So money times work, so then I'm displaying that I have this much free time, which is money times work, money. So there you go, 800 monies. All right, I hope that was easy to understand. I can also change this to, let's say, plus, and do the same thing, which is gonna come out to 60. So now it says I have 60 money. So, and then we can change this to subtract, and we can run this again, and it will subtract to negative 20 money. Negative money. All right. So that's pretty much what this chapter is discussing right now. You could make it more complex by like adding like your real money into this. So basically, you could say money, sorry, money available. Okay, and then you could just have this be money available. Sorry, I'm just trying to show like a real world example of what I mean here. Okay, so that's money available. So let's say that you have, you could make this like a lot more complex too. Like let's say that you have 5,000 monies, and let's say that you work 40 hours. Let's say that you want to spend, let's change it to spend. I know that I'm spending quite a lot of time in this. I just want to show it to you. So let's say that you spend 3,500 on your monies. So now your money available is going to be money which you have is 5,000, and then you subtract 3,500 from it. So what will end up happening is that you will get this 1,500 money. Now you could make it like, I shouldn't go further into this, but you could make it so that the user actually inputs the money that they have. So you could literally create a program that you could use to calculate your entire income, how much you're saving, etc., etc. It can get way further, but that's the gist of it. So anyways, in this example, I just wanted to show you how this works. So, and that's just a basic example. You could also use like multiple things too. Like you could like add numbers into this. Like you could do, sorry, what is happening? Okay, what? I did something wrong. This is not good. No, stop doing this. I have no idea what just happened. Anyways, that's just the example. I'm actually gonna end this, and I'm gonna start it up one more time here. So the reason why I'm using 2012 is because that's what my professor wanted. So I'm just doing what the professor wanted. So I don't know. Come on. Okay. I can open one of the projects. I think it's 2.7. Yeah. Okay. And we're back to where we started. Yep. And it's working fine. I have no idea what happened there. If it happens to you, close the program and restart it, and it should be fine. All right, moving on. Sorry, I took like a long time there, but I just wanted to get it straight. Insert, is it? Ah, yes. Oh, okay. Yeah. All right, so what happened there was I accidentally hit the insert button. I have no idea how that happened. Don't ask me. And basically, when you hit the insert button, it does the weird stuff which you don't want. So do not, if you press it accidentally, just press insert one more time, and you should be fine. And it works in many editors, as Daniel has stated here, which means that if that happens, hit insert again, and that should fix it. So I just learned something new today. This is good. This is great, and a great way to actually mess up someone's day, because they'll be like, "What is happening? Why is this working this way?" You know, it's a funny way to ruin someone's day. Yeah. All right. So that chapter, the examples that I gave is the section just does that. Like it's pretty basic stuff, so you don't need to worry about it. Um, so we're gonna move on, and we're gonna go into this thing called integer division. When both operands of a division statement are integers, the statement will result in integer division. This means that the result of the division will be integer as well. If there is a remainder, it will be discarded. For example, look at the following code. Double number, 5 divided by 2. This code divides 5 by 2 and sends the result. Sorry, I should just read this to myself and then I'll explain it later. Number equals 5 divided by 2. I see. So the example is showing what integer division is showing is that, let's say that you are dividing by using this system. So let's say that we double number, okay? And then we double number is equal to 5 divided by 2, okay? Now, when that happens, what you will assume is that it's going to give you 2.5, but your number is number and L. Okay. So you would think that this would give you 2.5, but instead it will give you 2. It's going to take away the right side. So how you want to divide numbers by using C++ and maybe other languages as well is you want to assign the number like this. So instead of 5, you want to put 5.0 or 5.0, sorry. 0, not O, 0. All right, okay. So now we'll run the same program again with the change here. Okay, so here we go. And the number is 2.5. Wow. So when you're dividing, you just need to put the 0.0 at the end of it, and it should work fine. So, all right. So with that said, let's move on to the next stuff. That's something important to remember, because when you are dividing stuff and you want the decimal values, you want to add these zeros there. So always remember that. Okay. Calculating percentages and discounts. Determining the percentages is a common calculation in computer programming, although the percent symbol is used in general mathematics to indicate a percentage. Most programming languages, including C++, do not use the percentage symbol for this purpose. In a program, you have to convert a percentage to a floating point number, just as you would. Yep. So basically, when you're programming, you just need to convert the percentage into a number. Like for example, let's say that you want to convert 50%. This would be written as 0.5. Let's say that you want to convert, I don't know, 5%. It would be converted to 0.05. 10% converted to 0.10, etc., etc. So that's that. So whenever you're dealing with percentages, which you will be if you're programming, you need to convert it into a decimal value. So okay, let's look at an example. Suppose you earn 6,000 per month and you are allowed to contribute a portion of your gross monthly to retirement plan. You want to determine the amount of, oh, okay, well, this is a lot of code. Basically, it's just showing you how to calculate the money. I suppose it's best for me to write this down just so that you know what is happening. Let me just make sure the time here. It's 3 hours and 20 minutes. All right. So what we're gonna do is we're just gonna write the entire program here instead of doing that. Now, for the majority of the things that I've done, for the majority of the code writing that I've done today, this library I only used it I think twice. You don't necessarily need that, so you could actually just keep it like this. So with that said, let's get started here. I'm not going to write any of the comments. I'm just going to write the code, even though the comments is very important, but I'm just going to write the code instead. Since we're dealing with percentages, what we're going to do is we're going to contribution. You're going to, sorry, like trying to do this. We're going to add the 0 because we want the decimal number as well. So, okay. So the next stuff is the calculation, in which we're going to do contribution to be equal to monthly, sorry, did I do that? Yeah, okay. Monthly pay times 0.05 C out. I'll explain this a bit more as we get further into it, but this is a good way for you to know what is happening. Oh, sorry. Also, please note that I am also learning this as I go on, so there might be a couple of things that I have not explained properly because I don't understand them, and Daniel might have not caught it or something like that. So if that is the case, you know, like I'm just learning. If you have any input, please post on the video after it's done, after the stream is done, because I'm looking forward to learning this more because it's something that I must do. So any tip helps. Times 0.07 C out, 7%. I don't know I don't use the money symbol very much, so it's a bit difficult for me to know the exact location of it from memory. Contribution, yep, per month. Oh. And the last one is 10%, which I can do, but I'm not going to do because I'm sure that this code should be enough to basically show you what is happening. All right, so we're just gonna do this. Okay, so it's 5% is so $6,000 of 5% is $300 a month. So let's say that you spend money on your credit card, okay? You spend money on your credit card, and let's say that the interest rate is 5%, and let's say that you spend $6,000 on your credit card, and there's an interest rate of 5% on your monthly bill. I'm doing this wrong. I don't think this is how this should work. Let me see, 1 second. Okay, so the program calculates the amount of pay that will be contributed to a retirement plan if 5%, 7%, or 10% of monthly pay is withheld. Okay, so if these amounts are withheld for your retirement plan, you will be getting $300 per month if it's 5%, $420 per month if it's 7%, and I believe the last one is $600 per month if it's 10%, which is not here. Okay, all right, that is cool. So basically, the purpose of this program is to just show you and myself that sorry, it's like all messed up. Okay, to show you and myself that how to calculate this stuff pretty much. This is using the floating data type because it is dealing with decimals. So whenever you're dealing with decimals, you want to use the floating data type, in which it is float, double, and I believe long double. So let's see what happens if we change this double into a float. I'm curious. All right, let's end the program. It still works, but we are doing double just because we can, just in case the number gets too crazy, I guess, or something. So with that said, that's pretty much it. Oh, sorry. So with that said, that's what actually. Let me see. Oh, average live view duration is 31 minutes. Total view time 6 hours. Peak current 3. That's cool. That's some cool stats that YouTube has. Okay, so we're gonna move on here, and we are gonna go to the next page. Calculating percentage discount. So basically, it's just using basic mathematics to calculate the discount cost, etc., etc. Like if you wanted, you could just make like a program in which like you could just immediately tell how much you would save at a specific point. And if you learn how to code for like, let's say, the iOS or the Android stuff, like you could basically code a program, put it inside your phone, and then you could just use it to calculate on the spot on what you want. So basically you look at the price, you put the percentage off, and boom, you get the value. Easy, you know. So it is pretty useful when it comes to that, and I might do that in the future, but probably not because I don't shop a lot. So maybe when I have more money than sense, or if I have more money than sense, I might do something like that. But for now, I'm not going to do that. But it is useful in a lot of situations. You could also use these calculations in checking to see how much would you have to pay the card monthly if you got like a credit card or something like that. So okay, so moving on. It's pretty useful. This is really useful for real life. So in the spotlight, using modulus operator and integer division. The modulus operator is surprisingly useful. The how do you say it? The modulus operator is actually this thing right here, which is the percentage sign. I don't think we have seen that yet. For example, suppose you need to extract the rightmost digit of a number. If you divide the number by 10, the remainder will be rightmost digit. For instance, 123 divided by 10 equals 12, with a remainder of 3. In computer programming, you would use the modulus operator to perform this operation. Recall that modulus operator divides an integer by another integer and gives the remainder. This is demonstrated, blah, blah, blah. Me reading this is not helping you in any way because I'm just reading it so fast without explaining anything, but we'll go through with it for now. So this is using a term called, that is loud. This is using the term called rightmost digit. So basically, let's write like a small program here. Give me 1 sec. Let's do an int number. 1, 2, 3, 4, 5. And that with that, let's do int. Why am I doing that? rightmost. All right, so basically what the program is doing, it's taking, let me just make sure here. This program extracts the rightmost digit from the number 1, 2, 3, 4, 5, and the rightmost digit number for this one is 5. I wonder if we change it to 6, it's going to become 6. That is my guess. Let's see if it works. And it does work. So basically it's just taking the far right side number and it's just stating it there. So that's pretty much it. It's fairly simple. I'm trying to think of an application where this would be useful, but I don't know any right now. Maybe in the future we'll get to see more of this. Most likely, yes. All right. So we're gonna move on, and maybe we will need to use this again. This program converts seconds to minutes and seconds. So basically, give me one moment here. I have to take this call. Sorry, I had to take that call. All right. So basically, the next section is basically showing me how to. It's just basic stuff like guessing how to extract seconds to minutes and seconds. Kind of weird. I guess it's a bit difficult to explain, but okay. So basically, what it's saying is that it's just letting me know how much time is 125 seconds when you convert it to minutes, and in that case, it's 2 minutes. It's not very difficult so far. All right, so we've reached a checkpoint here. Is like the reason why I didn't write the previous code is because it's pretty basic. I'm sure that you could figure it out. You could assign an integer value of 125 to the total seconds, and then you could do like the division with, like, we know that each minute has 60 seconds, and blah blah blah, and 2 minutes is 120 seconds, and yeah. Okay. Is the following assignment statement valid or invalid? If it is invalid, why? 72. So what it's asking, right, so this is a review. Basically what it's asking is that in the following assignment statement, oh okay, is, sorry, not in, is the following statements assignment statement valid or invalid? If it's invalid, why? Okay, why? Whatever. And the statement that is telling me is this one right here, which is 72 equals amount, and then that. And we've discussed this before, in which we said that you can't have it like this. You have to have it like amount equals, because you're giving the value to amount, you're not giving the value to the number 72. In addition to that, the number 72 could be used, but it's but not like that. And if it is used, it's generally used as a data type. No, sorry, char type, a character database. Sorry, what am I saying? Okay, sorry. Basically, the term 72 is a letter when you in the ASCII table. I'm not sure what that letter actually is, but it is an alphabetical letter. So, which is the reason you could use it to say something like for. I could give an example now, but we've already discussed the character data type, so I don't want to like write another program to explain that. I hope that you understand why the statement was invalid, because we have discussed it. So we're gonna move on. How would you consolidate the following definitions into one statement? How would you consolidate the following definitions into one statement? One. Huh, that's interesting. Okay, so this is what the question is asking. How would you consolidate the following definitions into one statement? Now, I'm not like, so it's actually telling me that int x equals 17, and then it has a space 100 and it says int y equals 16. Sorry. What? Is that minus? No, I'm not doing minus, I'm doing equal. Why am I putting minus there? And then the last one is int z equals 28. Now it's telling me to how to do it. So I think what it's asking me to do is to make it something like this: int x, y, z, x equals 7, y equals 16. Sorry, 16, and z equals 28. I think that's what it's asking me to do, like this code here, but I'm not sure. So I will call upon the Daniel. Okay, let's see here. All right, so we will wait for Daniel's response, and as we wait, we will look at the other question here. Well, I will look at the other question here, which is, what is wrong with the following program? How would you correct it? Okay. Okay, so while Daniel responds, I'm going to start writing the other stuff that it's asking me to do, which is, it's telling me that number equals 62.7. I forgot to do that. And it's telling me that to double the number value, or double the number of string, I don't know, number, and then end line. Okay. So I don't know actually how to check for answers in this book, which is kind of a problem. All right, so ah, Okay, so how you would do this then is that what you can do is you could the answer to this question would be then this right here, which is boom, right there. Why? Because I actually didn't know this, but you could actually just do it like this instead of putting int, since all of them is the integer values, you could just write it in just one big stuff instead of like writing int 7, int 16, int 28. Okay, that makes more sense. All right. So the second question, well, the third question was asking what is wrong with the following program. So it gave me this program and it said what is wrong. So number first thing is wrong. We have this, which is correct, but at the same time, it's not doubling the number. Like it doesn't know what to do with like number. What is number? So what we need to do in order to fix it is just change this. And now it'll work fine. You will see here shortly. There it is. There you go. Done. Okay, so that was an easy question. Is the following an example of integer division or floating point division? What value will be stored in portion? So let's see here. Let me add this. Is the following an example of integer division or floating point division? What value will be stored in portion? Okay, so now it is asking me about this. I'll show it to you in a moment. The portion is 70 divided by 3. Okay. So the question is asking me is the following an example of integer division or floating point division? And the answer to that would be, once I pull out the calculator here. No, actually, I don't need the calculator. I know that 30 times 20 is 60. And I know that 30 will not reach 70 after that, because 30 times 23 will be 69, which is not going to reach there. So this has to be the floating point division, because it needs to have a 0, because it's not going to be it's not going to be a number without a decimal. It's going to have a decimal. Like I can actually show it to you really quick. Actually, let's just use programming to show that. So what I'm gonna do is I'm gonna do 70 times, well, what is happening? Okay, divided by 3. Okay, so now it's going to give me the value here of 3. So which is right here, this one. Which is 23.333. Now, if I use the Windows calculator here, and I did 70, oh, wow, that was loud. 70 divided by 3, this would give me 7. See? So, there you go. And that's your answer. Now, this is a good example to actually show you long double, which is right over here. And now this is gonna make the number even bigger. Okay, it didn't make it bigger. I don't know why no, why? I thought it was supposed to make it bigger, but maybe not. Maybe because the number 3 keeps on repeating for a very long time, it decided to just not even bother. So I don't know. Let me try something different. This is, do not pay attention to this. I just, no, actually, never mind. I don't even know how to use this right now, so we're not gonna even bother going there. Anyways, you don't know what I'm talking about. Anyways, so that's how you get it. Now, if you had just, let's say, int number, and then you did this, what you would get is just 23. You will not get the decimal places or anything like that. So, which is the reason why it is important to use the floating point division when you want the decimal stuff. Okay. Comments. Concept. Comments are notes of explanation that document lines or sections of a program. Comments are a part of the program, but the compiler ignores them. They are intended for people who may be reading the source code, which is the reason why I have this stuff here. As you could see, these are comments. You can write comments in the ways that I know it so far is in two ways, which is the two slashes, and then there is this one right here, which is a slash and the multiplication sign, and then you end it with the multiplication sign and the slash. So I believe these are called the forward slashes. I'm pretty sure. Let me just, no, these are called the backslashes. Okay, so there you go. Let me see what else it has to do here. Right, so another thing to note is that when you are writing your program, you want to explain what each of the section does. Like, for example, you want to explain what does int number mean. The int number is the division, the example problem to explain why floating point division is useful. And then you would write this for like the problem, or the equation, or, and then you would write user outputting to user, I don't know, and then you would write pausing the command prompt screen. There you go. So then you would write all of this like stuff out, so that way the person that is reading your code knows exactly what you're doing and why you are doing it. So that's pretty much it. It's really important because if you don't have these and a person is looking at your code and saying like, what is this? Why? What is this? You know? So yeah. Anyways, moving on. All right, it's also useful to add the comments to your calculating stuff, like for your financial stuff. Because if you want to make an edit or something, and let's say that you have like a large, like a long lines of code and like stuff like that, I think comments will be very useful, because then you could adjust it very easily when you have to make a change to it. Like, let's say that you're getting more money now, or your interest rates increased or whatever. So after that, moving on, which is section number 16, named constant. Literals may be given names that symbolically represent them in a program. Assume the following statement appears in a banking program that calculates data pertaining to loans. Amount equals balance, blah, blah, blah. Okay. Let me read this through and then I will get back to you soon. Named constant. Concept literals may be given names that symbolically represent them in a program. Okay, well, I am pretty tired after doing this for close to 4 hours now. Yeah, definitely close to 4 hours. So, with that said, I will continue on from chapter number 2, section 16, and we will learn more about named constants. which are literals, maybe given names that symbolically, I will learn how to say this word properly too, uh, represent them in a program. So, um, and then we'll move on to, let's see here, programming styles. We'll move on to the review questions and exercises to make sure that we understood all of the content there. And then we will move on to chapter number 3, in which we will learn CIN, which is user input, which is an awesome command, and you will learn more about it later, or we will learn more about it later. So with that said, let me just look at my face. Thank you for watching, and I hope you have a good day. Take care and goodbye. I hope this was insightful, and if you are struggling in computer programming like me because your teacher is not very good, I wish you the best of luck. And if you're not comfortable with this, then I suggest that you might want to look into other professions, because there is more where this came from, a lot more. So as for me, I must go through with this, so I will. But if you have a choice to change something, please do so. With that said, goodbye, and until next time. Ta-ta. Bye-bye.